Power analysis part 1. The embedded system allows you to measure the power consumption of the CPU while it's running AES. Use this information to leak the key via dynamic power analysis. Okay, so we've got a port number. We'll encrypt anything we provide and provide an output trace of the CPU's power consumption. It says that's correlated with the Hamming weight of the bits being processed. We need to figure out how to deal with the noise. So one of the nice things about Python is you can often find a package for pretty much whatever you're doing. And so I have this side channel analysis framework maintained by eShard. So power analysis is a side channel attack. We're going to get the power information. We're going to attempt to derive the key from it. We're going to also need to build a trace set with their scared library and estraces. And then they have this tutorial here on doing a chosen plaintext attack. We get to pick the plaintext, so we can create this chosen plaintext attack, and we're going to look at Hamming weights. So we've gotten that hint. So I've got some code here where I've tried to put this all together. We used Pwn tools to connect to the server, the scared library, and then I'm going to create this trace set from things in memory. And we're using numpy arrays. So my first routine here connects to the server, reads the prompt, sends the plain text in hex 32 characters, receives everything between the open bracket and the closed bracket, and makes that a numpy array. So let me show you what that kind of looks like. Right, so it reads up to that first colon, then we put in 32 characters. And then it gives us back this big array of power traces. So we're going to read from that open open square bracket to the closed square bracket. Okay. So we create this chosen plaintext attack, and we're going to use the FirstSubBytes function from AES encryption. We're going to use HammingWeight, and we're going to look for the biggest values. We create empties arrays of plaintext and samples, and then I'm going to create 512 samples. I don't know, maybe that was too many. I'll print the iteration. I'll create some random bytes. I will then append that to the plaintext. I'll call this routine to talk to the server, which gives me back the power things, and I append that to the samples. I then create the trace header set using those plaintexts and samples. I run the attack, which is almost like magic, right? It does all of the power correlations for me, looking at what AES would be on the plaintext. And we pick the biggest score, and we print out the key. And then I'm going to need to stick that key in the picoCTF format. All right, so need to get the port number right, 59235. So now it's going ahead. It's going to run those 512 iterations. I'll pause the video here. Okay, so it ran, it printed out the key. I hardly had to do any work or thought here. And so let's check and make sure it got it right. So picoCTF, bam. And there it goes.